So again, why is the cloud interesting? We talked a little bit about this earlier, and I'll kind of hit both industry and academia, right? So in industry, from the scalability, I can't get the scale I want internally in my data center because I'm limited to the size of it, right? Okay, well, why don't I just rent some computers by the hour in an external data center? So this is an example that I can go out and use 5,000 cores to run a high-performance computing experiment, right? Not on my computers. Elasticity, a great example right now that's going on for us. You know, let's picture the NBCOlympics.com, right? Let's wait about 3 weeks and say, I wonder what the web traffic on NBCOlympics.com is going to be, right? Or wait about 2 years, right? So here's a case where you've got these kind of bursts in demand, and I want scale when I need it and scale when I don't, right? So I want to decrease my scale. So I would guess that the web traffic on NBCOlympics.com is a lot higher right now than it will be in 2 years from now, right? So wait another 4 years, that scale is going to go back up. So there's a lot of information out there talking about the infrastructure that people are putting behind the scenes to get live streaming audio, live streaming video, web traffic, websites all ready to go for this big event, obviously, that's happening over in London right now, right? So could the cloud be used to help scale, out and back in this elastic model of, well, all of a sudden I just had everybody in the world that's interested in the Olympics hit my website because they want to see who's winning the 100-meter IM swimming event tonight, or whatever it ends up being, right? So again, back to the utility computing, right? This is very similar to I rent an apartment and I need to pay for my electric bill, right? You've got a utility bill. I can do that same thing with this utility model of I can go out and literally pay for the computers by the hour to be using. It's a totally different model than I'm going to buy all this hardware and put it into my data center tomorrow, and it's going to cost me $1 million, right? And now I'll start using it, right? This is a totally different charge model. So as you can see, here's some examples that I've already started to touch on, but high performance and high throughput computing, right? Could we actually use these clusters and build scale that maybe is not present today in a data center? I'm a small biotech company, and I don't want to pay for a large data center. I'm going to use the cloud for my analyses. Online game development. Actually, you may find some of your biggest cloud users are Facebook app developers, right? I better be prepared for the scale that if my game becomes popular, am I ready to scale it? Because if I've got 10% of the Facebook users hitting my application, all of a sudden I could quickly hit, what, 50 million people hitting my stuff? So I'm not going to build the infrastructure. I'm going to build it on top of a cloud that allows me to scale in that mentality, right? So, and again, back to scalable web development, right? NBCOlympics.com, Indianapolis 500, right? Probably has access only right around the month of May or something like this. So these are examples of where the scale and this burst in demand goes up and down, and I want to be able to appropriately handle those events. Is there a question out there? Yes, go ahead. Okay.
Everything is nice, but what about the data security? For example, a company, how can it upload their data if it cares about security?
Sure. So security
or secrets, I mean.
Sure. So security is always a big topic when we talk about the cloud. There are common mechanisms that can be handled for dealing with secure data in the cloud. I mean, obviously, number one case is encrypt your data on disk, right? And so there's public and private key cryptography is pretty standard way of doing this. The other thing that I would say out there is there are varying levels of data that a company deals with. And so some companies that say, I'm not trying to get into it right away, well, maybe I'll learn from my easy use cases, right? So there's industries, for example, that collaborate with academia. I can look at public data. There's plenty of companies, so again, go back to the pharmaceutical industry, and there's public cases out there of people talking about using the cloud. There's tons of public data sets. So we'll take one example of the 1,000 Genomes Project. Amazon's published that data, with the NIH, the 1,000 Genomes Project's been published out into Amazon as a public data set, right? So here's a case where a pharmaceutical company could actually get rich knowledge out of a public data set with no security or intellectual property risks with using it, right? So here's a case of I'm going to actually get analysis off my internal cluster and run it in the cloud as opposed to run it internally, because I've got little chance of, if the data's stolen, so what? It's public data, right? But I can get some analyses out of it. and actually run it out there. So these are just examples of how people are trying to get into the cloud without having to maybe take some of the risks out of security, right? But again, like I said, what default is you come in with your security thoughts on how are you going to secure your data out of the gate. You don't make security your last topic of conversation. You make it one of your first, right? What am I going to do out of the gate to encrypt my data? What am I going to do out of the gate to keep my keys secure? And work through these kind of technical things. But these would be the things that the lawyers and all of your other people are more interested in, right? The other thing that I've said to people out there is there's kind of a change in mentality of I'm working at Starbucks and I'm on a virtual private network, right? You know, technology is advanced enough now that I can be on IU's network, sitting there literally in a secure session, working in a public internet area, right? And so if you start to think about it from that mentality, right, I can start to translate some of that into the cloud, right? Maybe a little bit different technology, but some of the same overlying principles of, you know, you have to continue to learn how much risk am I willing to take and what am I going to do to actually secure my risks in that, right? There's also things called virtual private clouds that allow people to get these machines within their data set, within their IPs. So you could be actually in Amazon's data center, but within your own network because you've created this virtual private cloud. So your data may still reside on block storage that's stored in the cloud, but you could also say, look, I'm going to say as a principle, I'm never going to store data on block storage. I'm only going to put data in as bursting. I believe bursting is another topic that's going to be covered through this. But I'm going to literally burst out from my internal cluster out to the cloud, do some work, and then bring my results back in and never persistently store that in the cloud. So there's use cases to try to get around some of these security concerns that people have. Hopefully that helps. So we talked about industry. Let's talk a little bit about academia. So why would the cloud be interesting for us as academics? One of them is, and we'll talk a little bit more about this, Stephen will come up and talk a little bit about reproducibility, right? So this goes back to, I'm an application developer. I have a specific domain that I like to deal with. I'm not a computer scientist. Can I share my work with others so that they can either reproduce my experiment or we as a group are working together across academic institutions to collaborate on something, right? Well, the cloud allows you to have then the same computer running, the same instance types, working through all the details then that says, well, look, all I want to be dealing with is an application up here. I don't want to have to deal with how do I install it? How do I configure it? How do I work through all that stuff? Well, back to my machine image example, right? As soon as you get it installed and configured, you can take a snapshot of it now and say, here's my software at version 1.0. Right? Any of us that want to use it on the project team, go run that machine image, right? And it's got the software already installed and configured for you. So you're already a lot further along with trying to bring a new project member onto your team because you already have software installed and configured for them to use. Now, I would argue that you actually want to have that knowledge down deeper and say, how do I recreate it, than to just give them this, you know, here's a snapshot of it. And we can talk about that a little bit more in detail. But really, it just allows you to then say, we can reuse machine images across, or it can have something registered out there that we can use, and we're working off the same kind of base, right? So I'm looking at a paper as a graduate student, and I say, well, how do I reproduce that experiment that that person did, right? I know I need to include them in my related work section. How do I reproduce their experiment, right? Well, the beauty of the cloud and machine images and all of this now is it gives me the ability to now actually go recreate somebody else's experiment, right? How do I get their installed and configured and everything back to the sample data set that they use so that I could say, do I have an apples-to-apples comparison with the work that they're doing, with the research work that I'm doing, right? The cloud helps you do that in this virtualization technology as well. So virtual environments allow you to then go in and try to do a lot of variety of uses and configurations. I think there was a question, like I said earlier, about how do you know how many map tasks you should do in a MapReduce cluster? Well, now you can actually experiment with that, right? I can actually build a cluster, change my parameters, how many cluster nodes should I have, how did it work, scale it down, redo it again, let's add nodes, let's decrease the nodes, whatever, right? And you can start to look through and say, how did my algorithm scale? Did it actually work for me or not, right? And you can work your way up and say, oh, I got a bottleneck at 100 nodes. Why did I get that bottleneck? What was my problem, right? You've got this cloud environment now that allows you to do that, right? So gives you, and for those that aren't computer scientists, you can actually dig into the foundational components of operating systems and all of that. I mean, this is literally a test bed that allows you to understand more about the systems that you're using.